Okay, so today we're going to follow up on that cloud lecture from the other day. We'll finish the PowerPoints. And so where we'll start is with a little bit of a rollback to where we were. So back when we talked about cloud attributes, right? And some of the things that you would need to be a cloud service. So we skipped ahead a little bit, did a lot of content around service-oriented architecture or SOA. Now we're going to go back in, fill in some of the gaps, and we'll do a recap of SOA a little bit. Okay, so where shall we start? Let's start with shared resources, then we can even roll back a slide. So reason why cloud services save money over businesses having all the same stuff under their own roof is because of demand smoothing. Now, the idea of demand smoothing is simply that, well, do you guys, any of you ever been to a standalone Baskin Robbins? They're unusual, right? Baskin Robbins is now with Dunkin' Donuts mostly, right? Why is that? Why would you put those two businesses under the same roof? Possibly, but that wouldn't still necessarily make sense to put the same, right? I mean, I'm going to say, yeah, they probably are, but what's the logic about operations, about how the business operates? When do people buy ice cream? Summer, not much in the winter, right? It stands to reason that maybe people buy more coffee on the off, not in the summer, right? They probably buy other drinks like cold drinks, sure. What else? There's different things. Is ice cream typically something you have for breakfast? Is a donut typically? So you can see there's a lot of, if one side of the store isn't busy, maybe the other side is, right? That's demand smoothing. So if you have a Baskin Robbins standalone, 3/4 of the time it's not doing much, right? Not much sales outside of summer, not much sales, before mid-afternoon, let's say. Okay. Dunkin' Donuts, kind of the opposite. Same thing with cloud. Okay. If you are a cloud business, you have all this hardware under your roof, all this network capacity, and ideally it's all fairly busy, right? Now, it's not going to be, any cloud operation is going to have busy times and quieter times, but the busier it can be overall, it's going to have a flat demand curve, and that means you can get more use out of the hardware you have. So typical, I'll give actually a historical example. Some of you may have heard of America Online, okay, which was big in the 90s. For a lot of people, roughly my age, that was the first internet service provider they had. Your parents probably had it, okay? So the thing with America Online in the 90s, it experienced this weird pattern that took them literally a few years to get caught up with. So the x-axis here will be time of day. So the typical demand pattern at AOL back in the day was that it would be pretty quiet through the morning, right? I'm just actually going to draw a pretty long curve here. It'd be pretty quiet till about when? Till about 5 p.m. And at 5 p.m., there would be this sudden massive spike in demand because everybody just got home from work and they all wanted to do internet stuff because that's what we did in the 90s. Okay. And then, it would be busy till about 9 p.m. or so, and then it would taper off to not very much. Okay. So, 5 p.m. And let's say 9 p.m. about here. And the reality was, if you wanted to get online and do, internet stuff, chances are you had to try to dial over and over for like 20 or 30 minutes at about, 5 or 6 p.m. until you were finally lucky enough to log in, right? If you've ever watched old-timey movies where they have that horrible screechy sound when you connect to the internet, that was like the happy sound. That indicated that you were getting in, okay? So with this kind of situation, AOL basically had two possibilities, right? Number one, they could add lots of hardware and capacity so that nobody has to wait very long to log in, right? But that's going to cost a lot of money. So, that was kind of something they didn't want to do unless they had to. The other option was simply let people wait, right? Let people wait during the busy times, which the advantage of that is it's free, but problem, but leaves AOL vulnerable to competitors, right? If some other ISP, internet service provider, can come along and say, hey, you won't have to wait if you join up with us, people are going to say, yeah, that sounds pretty good. I'm sick of waiting half an hour to log in. Okay. So this is a problem that in a variety of ways businesses often see. It's what's called a high peak to average. So ratio. Typing is hard. Okay. High peak to average ratio. And anytime you have a situation like that, you can either say, well, I'm going to manage toward the average, and those people during busy times are not going to be served well, or I'm going to manage it toward the peak, and then I'm going to have to spend a lot more money, right? The same thing if you have a call center, there's going to be some busy times. Do you have a lot of people on hand for that or not, right? Anything is going to be like that. Now, with cloud, let's undo some of this. Okay. So if we're talking about cloud, we have a similar problem, right? Where individual businesses, they might say, hey, I want to manage my own stuff under my own roof. Well, their demand profile is going to be pointy like that, right? Maybe not exactly like AOL, but it's going to have busy times and not so busy times. And a typical number for a business is basically that typical business will need something like 7 actual servers to keep up with 1 server equivalent of average demand, right? So because of this peak to average problem, so for every unit of average demand, typical number 6, 7 servers are what they're going to need. Amazon, on the other hand, their profile is going to look more like this. It's going to have a busy time, but it's going to be flat. And Amazon sees, again, rough numbers, they don't give exact stuff, but people in the industry who know, Amazon needs about 1.5 actual servers to keep up with 1 server equivalent of average demand. Okay, and this is where the money comes from. The idea is, even if Amazon is charging a fair amount extra, like they're charging double what they need to, the fact that they only need 1.5 units of hardware to keep up with 1 unit of demand means these guys, they got to get 7 units of hardware. So even if Amazon is charging double, like they're charging the equivalent of like 3 units of hardware, it's still a really good deal for the individual business, right? Okay. Does that make sense? I hope it does. Okay. So that's the basic idea. So we go back to the slides and we say here, okay, cloud providers typically have to be very, very large. One of the economies of scale they get is a smoother demand profile. So if they have many diverse clients with different daily requirements, right, that's going to help. Now, it's true that most of these big cloud services, there's not one global data center, right? There tends to be, individual data centers, which might encompass, at most several time zones. So you get some benefit out of that, a smoother profile, but it's not as smooth as it could be. And there's other ways that demand smoothing can happen, though, even within that zone. Besides just time of day, you can also have time of year. Some operations are busier in the summer. Some of them are busier in the winter, right? Some of them are busier on weekends. Some of them are busier on weekdays. So the demand profile, you're not going to get it perfectly flat, but it'll be a lot flatter than that, big spike at 5 p.m. that AOL used to get. All right. Now, this is another case where scale advantages matter. So if you're a competitor going up against one of these big cloud services, you're not going to be able to smooth demand as well unless you're really lucky and happen to get a set of clients whose demand needs exactly offset each other, right? They're exactly, one is busy at time A and the other is busy at time not A. Another advantage, the overhead costs become pretty small the bigger you get. For example, if you go from, if you have 100 times more servers, you're not going to need 100 times more network administrators, right? Or 100 times as many system architects. You're not going to require a 100 times larger physical space, and you're not going to require 100 times as many security personnel. And finally, cost advantage. So if you are a big cloud provider and you can offer that service at a lower cost, then that's going to be a barrier to any new competitors coming in. They're going to have to try to match not only your quality of service, but also your cost in order to be a good competitor. So shared resources, this is an important concept. This is why cloud services, you might think that, gosh, why is it better to have, a few servers under my roof as opposed to a few servers in the cloud? Well, the reason is the cloud actually needs less hardware to do the same work because of demand smoothing. Okay. So, let's go ahead. Okay. Oh, let's do a question. Let's keep people doing stuff. Okay. We're going to redirect it slightly. Let's do 21. We'll do a little review. Can you see? Yeah, you can see. All right. Did that go? In unrelated news, my son turned 13 lately, so we went to Dave and Buster's over the weekend, and I don't know what they must have been clearing out old inventory or something, because the claw machines, like every time, usually like you never get anything, right? But the claw machines, they were just grabbing everything just about every time. So I got the complete set of Pac-Man plushies now. It's very, very satisfying weekend. Nice, yeah. Yeah. Anyway, all right, you got it? Let's do 10 seconds. Eventually, I'm going to have a class of students that are like, what the hell is Pac-Man? Probably near the end. Do you guys, who here is familiar with Pac-Man? Are you, if I say Pac, okay, good. Thank God. Okay. All right. All right. One of the saddest things about getting old is that everything you love goes away. So, not that Pac-Man was really that great of a game, but for 1980, it was pretty good, I guess. Okay. So what's the right answer for 21? Correct answer is E. If you said E, that is correct. Apparently this is a tough one. Oh, you guys did better than the morning class. That's good. Okay. Well, let's talk about this, right? The one thing that you really can't just have, right? Anybody can build a big cloud system, right? Given enough resources. Google has one, IBM has one, Facebook, they all have their big cloud systems. And advanced security tools, well, that's not really core to a recommender system anyway. Okay. Data about stated customer preferences, anybody can pay for a bunch of surveys. What kind of stuff do you like? So stated customer preferences, those are relatively easy to get, but like we said, they're not always that useful. And partnerships with book publishers, oh geez, book publishers are happy to make partnerships with just about anybody, right? More sales. The real unique thing about Amazon, 20, 30 years of transaction data over a very wide line of retail products, right? If you want to do a recommender system about people who bought this also bought that, where are you going to get that information except internally from your own sales, right? And nobody but Amazon has anything like that much because Amazon has crowded out a lot of the other retailers online anyway. Okay, so the real one there is E. That is incredibly difficult to replicate. Okay. Cool. All right. So talked about that. Okay. I'll go through some of these. All right. So different models for cloud. So the two main ones are public and private. So I'll draw an image for that so you can see what we're talking about. All right. So it's always hard to grab things. Okay. Okay. So in the middle, right, we have a server. And up here, we got a database. All right. Down here, we got a client. Okay. All right. And these lines just indicate that the server is connected to many other machines. Okay. So in the public cloud model, you have this issue. Public cloud, all hardware typically holds data being used by multiple accounts or users. Okay. So I'm going to represent them with colors. So for example, a particular database machine might have, data from a variety of users. Likewise, the server might also be running applications involving data from a variety of users. Okay. Now, the issue with this always creates potential for vulnerabilities that would not otherwise exist, right? Obviously, the cloud wants to keep people only looking at their own data, right? Not anyone else's, right? But sometimes vulnerabilities exist and are exploited by bad guys. Okay. And this is a thing that's going to happen. Anytime you put your data in this kind of public cloud environment, it's going to be what's called co-located, right? Put together on the same hardware. So there might be a bunch of different clients running applications, and that server has pulled data from a bunch of different places. And so you have data from multiple users on that server. And back in the database, if you find a way to hack that far into the system, you have access to data from multiple users there. Okay. This is a built-in feature, but so this is a risk, but the reason why people do it is you save a lot of money having your cloud set up this way, right? Because the alternative is simply you're paying to rent a specific batch of machines. The only way to have a bunch of machines be just yours is if you have actually reserved them all within the cloud system, right? And you tell the cloud people, hey, I want to reserve this block of 100 servers, all day, every day until I tell you different. Well, if those servers are busy, that might be a good deal for you. But if you have that typical high peak demand relative to low average demand, you're going to pay a lot more than you would in this model. Okay. But yeah, this leads to some occasional bad outcomes. About 10 years ago, it was a while back I started teaching this version of the course, but when I first talked about this stuff, and I said, hey, what's a case that you might have heard of? The iCloud hacks around 2010, right? And I would say, has anybody heard of the iCloud hacks? And a few people would giggle and be like, oh, yeah, we heard of that. Yeah. And the iCloud hacks. So it's worth mentioning. Apparently, it's a thing that people now send nude pictures of each other through, cell phones and whatnot, right? Apparently, that's a thing. And all that data is there somewhere in the system, right? Whatever app you're using, whatever system, it's on the server for a while. It's temporarily stored in a database for a while, right? Maybe if it's Snapchat, it's supposed to go away after 30 seconds, but those backup deletions don't always happen, right? Sometimes data gets kept because a server gets temporarily disconnected or otherwise has a hiccup and doesn't get the instruction to delete stuff. So in a variety of ways, that data can be on there. So what the bad guys would do, they would find some vulnerability on a server, right, like in iCloud, and they'd find a way where they could capture a whole bunch of data, right, from a variety of different users. Basically, they'd run a query that was somehow less bounded in scope and not just limited to their own stuff. They found ways to do that, and they basically pulled all the data off the server, and then they, somehow scan through all that data and see if they found anything interesting. Well, yeah, they found some interesting stuff, and a lot of famous people had their pictures up on the internet because of it. So there was that. The alternative to this is, of course, the private cloud. So private cloud means only one organization has access to the cloud service, right? Typically with a private cloud, we mean that it's the business's own cloud, right? So Google, they have their own private cloud just used for Google. Amazon has its own cloud just used for Amazon. Facebook has theirs just for Facebook. But it could be that a business rents out, space from a cloud provider, but only that business has access to it. So you might conceivably say, hey, Amazon, we want you to build a special private cloud for us so that only our business can use it, right? And then again, less vulnerable to hacks like that. Your data is going to be more secure, but you're going to pay substantially more for it. Okay. All right. There's other ways that sometimes there are hybrid clouds where you can kind of mix and match. If you're an organization where some of your data, you're very concerned that it stays secure, and other things you're not at all concerned that it stays secure, then, you might use public cloud in one case and private cloud in another. So there's that. Okay, those are your basic models though. Okay, so elastic leasing, metered, yeah, it's not very interesting. Service, okay, so next thing I want to cover is SOA. All right. So remember, the idea with SOA basically means, so SOA, service or oriented architecture, means building larger applications out of small modular applications, kind of like IT Legos, right? I guess you're supposed to say Lego, but everybody says Legos, so I'm going with that. Okay. You guys all know what Legos are. Okay. That's the idea. So I'm going to give kind of an example of how this works out. Okay. So imagine you have some large monolithic application, right? Monolithic means it's like one piece. It's a solid unit you can't break up. Okay. And suppose effectively within it, though, there are 5 modules. Okay, but they're not done as separate modules, but they're, 5 separate functions. Okay, and there's some kind of pathway that the data follows. So inputs go in and they go through some standard set of processes. Okay, maybe it goes to orange, then to yellow. Sometimes it goes through green to blue. Sometimes it just skips blue, or sometimes it just skips green. Okay, and then blue sends out the output somewhere else. Okay. So what often used to happen back in the day is applications were often designed without concern for any substantial modification later on, right? Just basically build the application now. If we need to replace it, we will. Okay. That was kind of the philosophy. Now, of course, everybody knew if you have an application, yes, you're going to have to replace parts of it and things are going to get upgraded and changed. People knew that, but it was a question of how much modification is going to need and how often they were going to be needed. So just, kind of push on the I believe button that changing this code and taking a completely different module and plugging it in there is going to be a lot of work, right? And the reason why there would be a lot of work is because in various ways, dependencies, right? For example, orange might expect that red delivers data through a specific hardware interface, right? Using specific memory addresses, right? So unless that data is bundled up in that specific way, this whole system is not going to work. So if you try to use code from a different application, it might totally fail, right? And this was a thing back, this would be like trying to run an Xbox game on a PlayStation, okay? They're just set up different. The code you write for one isn't going to work on another, okay? So dependencies like these, those would often happen. But if you've designed your system to be modular, right, basically what you're doing is you are taking all of this stuff out of that shell. And you are making it much easier to change, right? So the idea is if you're using service-oriented architecture, these individual modules are designed to be easily replaced and modified because they only exchange data through standard interfaces, and I'll add in independent of the hardware being used. All right. It's like the same way where you can go to a website and it doesn't matter what device you're using, you can still see the page, right? It might look better on one device than another, but any device, you can go to any web page and it's going to work. Okay. So the idea with that, not with service-oriented architecture, suppose you decide, hey, for whatever reason, this orange module just isn't working out and we want to replace it with a purple module. Let's do that. Well, the idea with SOA is that it's going to be pretty easy to do that. All you have to make sure is that purple accepts the same inputs in the same format as orange did and accepts and produces output in the same format as orange did, or more generally, whatever yellow needs, and it's going to be okay, right? It'll at least function. And same thing, if you want to include a bunch of different options at that point, a bunch of different modules to handle different kinds of data, like we talked about the case of different credit cards or different shipping services, it's easy to bring in new ones into that situation. Okay, so SOA is a really important basic concept in modern IT. You know, most of your systems are designed, big systems anywhere, pretty much all designed from that. And cloud is no exception. Cloud's the same kind of thing. So you as a user, you don't need to know exactly where your things are in the cloud because the whole cloud architecture is designed to make it easy to move components from one piece of hardware to another, and it's still going to work well enough. Okay. All right, so all that stuff we kind of covered. Okay. Let's do another question. That's fine. We'll do a question. Let's see. Did we cover that one? Did we do 25? All right, let's do 25. All right, some cloud stuff today. All right, 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Ding, 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 ding. Okay. Correct answer? Yeah, there's B. All right. Let's see what Pip picks. Interesting. Well, Amazon does not primarily use RAM for storage, as far as I know. That would be exorbitantly expensive, given the size of Amazon's operation. Google has some tremendously big banks of RAM, though. It's possible Amazon does, but that still wouldn't have anything to do with utilization as such. Even if Amazon keeps it all in RAM, still you're always going to have this situation where some of it is going to be busier than others, right? The reason why Amazon cloud services get high utilization is just because Amazon is big. Because Amazon is very big, it is going to have a lot of clients with diverse demand requirements. Just like diversification in finance, right? If you pick a random bag of 100 different stocks, it's going to be pretty close to the index average that those stocks are from, right? It's just, central limit theorem, law of averages, whatever you want to call it. So high utilization is something, it doesn't derive from Amazon using any kind of special hardware or any particular hardware configuration. It's just Amazon's demand pattern is flat because, if you're a single business, you have that sharp peak, maybe at like 5 p.m. or during the daytime, whatever. But Amazon, so many users spread throughout a wider time, their demand curve is a lot flatter. So that's what high utilization gives. Okay. Alrighty. So next stuff, cloud migration. Well, actually, before I get into this, I want to talk a little bit about history of cloud. So, because this is worth mentioning, right? So all this stuff I've mentioned a couple times, cloud only really caught on around 2010, right? Which is interesting. You might ask, well, why not sooner? Well, the single biggest reason is simply this. Up until 2000, 2000 whatever X, that's a really awkward thing to write until, well, so up until the early 2000s. That would be okay. Up until the early 2000s, businesses often had predictable networking and other computational requirements, right? They had some kind of client server setup. They knew, how many employees were using which software and data storage, and and it was pretty stable. So for that, if you know what your requirements are, and it's pretty flat because you just have those employees there during the day, the trade-off from like giving up control of the system and paying the extra cloud premium and worrying about security, it's not a slam dunk that you're obviously going to be better off. I mean, you might say, yeah, okay, we're probably going to save a little bit of money if we go off there, if we go off to the cloud, but there's other concerns too, right? There's not a compelling business reason to do it. But as more businesses started doing more and more work over the internet, they started seeing not only massive data growth, but also sharper changes in demand during the day. Okay. So suddenly, not only are businesses, getting bigger, in a variety of ways, they have more data, transactions are coming in from online, other information from business partners, whatever, but they're also starting to see sharper upticks in, busy time, right? As compared to a client server setup where, yeah, a bunch of people are going to be doing Excel or something else under our roof, or statistical analysis software, whatever. And you know how many copies you have, right? Suddenly with this, wow, a lot of things are changing pretty fast during the day. So at the peak of that peak is getting sharper. So you ended up seeing something like this. And eventually at a point, businesses said, wow, you know what? Managing all this under our roof is no longer going to be cost effective. So we got to look for a different solution. So you would see something like this happening in the real world. So suppose circa 2000, your business has 100 servers, but for average demand, should we say 1,000? 100? Let's do 1,000. That's fine. But for average demand, you only need 100, right? This means, in a sense, you are wasting 90% of that hardware expense. Okay? So if the servers cost 10K each, right? 10,000 times 1,000, that's 10 million total, and 9 million wasted. Okay? Which in 2000, your business might look and say, wow, that's unfortunate, but what are you going to do, right? That's just the cost of doing business. Okay. So go on forward, right? Circa 2010, your business has survived. Yay. And now, and even grown. And you have 10,000 servers. Okay. But again, for average demand, you only need 1,000. So you are still wasting 90% of that expense. And once again, if the servers cost 10K each, and maybe, maybe they do still cost 10,000, but they'd be a lot more powerful, but maybe that's still what you have. If they cost 10,000 each, that's 90 million wasted, right? 10 times as many servers, 10 times as much wastage. And you might even look at that at 2010 and say, 90 million, that's unfortunate. But what are you going to do, right? Our data is really important. And, 2010, you might say there's not really viable cloud services out there. But you can look forward. Your business can project that in 10 years, you'll be wasting close to $1 billion. And as they say, that's almost real money, right? That's something to be concerned about at that point. And you say, yeah, we gotta get out in front of this. So between the availability of cloud services, and some of them we're starting to get a reputation as being good, like Amazon, and the availability of online analytics so that you have all your data up there. You don't have to download everything. But businesses, we're looking at that and saying, you know what, this demand peak to average demand ratio is simply not sustainable. And you see it in a lot of different places, like Intuit that I talked about the other day. They only recently spun off, sold off their last data center and went totally to the cloud. For a long time, they were keeping, their applications running on data centers, but they had that problem of seasonality, right? Everything you do in taxes has a pretty well-defined window where it needs to happen. And they don't want to pay for the hardware year round when it's only being used for a small sliver of that year. So this is a real thing. Okay. I don't know why the calculator app came up. That's a little odd. Okay. Questions, concerns, thoughts? All right. So that's pretty much the story right there. Okay. So other stuff, cloud migration. Cloud migration just generally, is the process of moving applications or data to the cloud. And there's basically 3 models for that, depending on what all you need to send and how you need to send it. First one is data only, right? So imagine all your users are still using pretty much the same batch of applications, but you just have a lot more data to work with. For example, you have some supply chain application that you've gone from having like a few data points per trip to many data points per trip. And those data points themselves are more detailed. Then you might, say, gosh, the amount of data we have is getting kind of out of control for us to manage under our own roof. Let's put it in the cloud where they can have massive database tables and we can, run queries on it all and do our analysis. So you might only migrate your data, leave all your apps under your roof. But if you decide to send out applications and data, there's 2 flavors to do that. First one is machine replication. Machine replication is basically making a copy of your system in the cloud, okay? Now, the downside of that is that you're going to have to, all the hardware that you have under your roof, you pretty much have to have the same hardware in the cloud to do a real, a direct copy. So you need the same models of hardware, more or less, and you also need to have the same number of machines. So if you're doing true machine replication, if some system runs on 100 servers under your roof, you're going to need 100 servers in the cloud. And so again, you're going to lose the opportunity to save some money up there because you're going to have to reserve that same number of machines. The advantage of it is it's easy to test, right? If the system works well under your own roof and you port it successfully to the cloud and it's running on the same hardware there, it ought to work fine up there, okay? It might be suitable to do that for smaller systems. Small systems that are busy most of the time and don't require a lot of hardware, you're not going to lose a lot by just doing machine replication there. But the cloudiest model is physical to virtual. Physical to virtual means all this stuff that we talked about SOA, right? This stuff, having your applications broken up into modules, deploying those modules at separate points in the cloud, and it'll be okay because they don't need to be co-located on the same hardware like they do in that monolithic application module, right? You've designed it so that all of these application components, it's okay if they run on different pieces of hardware. Okay. Now, the downside of this, physical to virtual, the good side is that's where you're going to save a lot of money, right? that one really goes with the pay as you go. So if, you need, 1.5 server equivalents on average throughout the day, that's what you're going to pay for. You're not going to pay for that peak demand all the time because you've reserved a specific number of pieces of actual hardware. The downside of it is that it's going to take a lot of testing. Quite often, dependencies are built into the system that people aren't fully aware of. And you would think, right? You would think that, gosh, people work with these systems all the time. Shouldn't they know all this stuff? I'm here to tell you, mistakes abound. Just listening into the projects that my wife manages, every day it's like, oh man, why didn't they check that? How did that fall through? So yeah, these systems are pretty complicated and people do miss things. So, but simple examples, right? Simple representative examples of things going wrong due to dependencies. Okay. Number one, suppose your system works fine under your roof because all the machines are connected directly with, super fast cables. Okay. That might be a problem, right? You try to put that system up in the cloud, you are no longer guaranteed that all of those machines are going to be connected with super fast cables, right? That's, you might say, well, yeah, they're designed as modules. Well, that's a dependency that's built in, right? Or you might have problems with data growth, right? I guess that should be number two. For example, your system works fine when you first send it to the cloud, but because it seems like you have infinite resources, you start gathering a lot more data and your tables become much bigger. And one day, running queries on them is simply too slow, right? So Google has a system called BigQuery that we'll talk about, designed for handling very large database tables involving like tens of millions of rows. And one of the things you often would see in real life is that a business would say, gosh, here's a query that took us a week, literally a week to do under our roof, and we send it to Google, and then boom, it gets done in a few seconds because Google has greater hardware capacity. One of the things we talked about with relational databases is those sort of operations work really well as long as everything can be contained on one chunk of RAM. When things start branching across into different machines, then all of those cross back and forth operations start having to happen at network speed, which is a lot slower, right? So, but even BigQuery, it does eventually bump into some sort of limit, right? It's not an infinite system, it's just a really big system. So if your database tables are really, really, really big, and the queries you're doing on them are pretty involved, well, eventually you are going to bump into those limits. Okay. All right, so that's cloud migration. Now, next thing, the three basic models of cloud. Okay, and I'll draw boxes for them. The first one, well, I'll draw the box first. Infrastructure as a service, or IaaS. Okay, with infrastructure as a service, this one means you get the hardware and nothing else, right? No operating systems, no other apps. Okay. Advantages of infrastructure as a service: maximum flexibility, right? Flexibility. Okay. So you can use any operating system, even a custom one, right? So maybe you have some custom flavor of Linux that you want. Linux is an open source operating system, so you can modify it yourself. Maybe you have some custom changes there you really like to keep. And any custom apps. you've designed. Okay. Downside, management headaches, right? Everything goes to you. Changes in the operating system, yours. Changes to the apps, yours, right? Anything like that, it's all yours. And hope you know what you're doing. Okay. So all that. So infrastructure as a service, sometimes in industry, they call it bare metal servers because you're just getting the machines, nothing else. And again, depending on what you're doing, that might be exactly what you need, but for a lot of businesses, it isn't. A lot of businesses don't really need to do custom operating systems. So the next option, platform as a service. And with platform as a service, you get a platform for running any apps you want. Okay, so you are provided with an operating system and maybe a vanilla database app. So for example, if you go to Oracle's cloud service, Oracle is the leader in relational databases. They know if you're going to Oracle as opposed to another operation, you're going there because you want to use their database software. So they'll just throw that in for free, okay? Because they know that's what you're there for. But in general, platform as a service, some flexibility and fewer headaches, okay? You won't change the operating system, although you have options, right? You can pick from different ones, but you're not going to go in there and modify it yourself. Let me lift that. Okay. And you can use any apps you want, right? Even custom ones. So you can design your own apps, you can use them, which can be useful, okay? So and for a lot of businesses, platform as a service is a good one. Because why? Because they have a need for custom apps, but they don't need customization beyond that. So they, all that other stuff is taken care of. They don't have to worry about it. Okay. The final one, software as a service. And you've all used software as a service, even though you might not have known. So with software as a service, you get everything pre-installed and ready to go, right? You get a set of applications and can use them, okay? Now, with software as a service, very nice if you just want to get going the first day, right? And your needs match the available applications. Okay, so some everyday examples of software as a service. Any of these big ones that you've used, right? Facebook, Instagram, right? I suppose Discord, whatever. And G Suite. G Suite is one that you've certainly all used. What's G Suite? G is for Google, right? So Gmail, G Drive, that's G Suite, right? That whole little bundle of applications. And with G Suite, what's there is there, right? You can use it. You can't do much to modify it. You can select options off of a pre-designed checklist. But the idea that you're just going to put a new application into G Drive, into G Suite, that's not really going to happen, right? Facebook, if you want, I will say, I'll add this though. Very important clients might have input into app changes, right? So that's a possibility, but most just use what's there. All right. So those are your three cloud modules, three cloud models. Infrastructure as a service, right? You just get the hardware. Platform as a service, You get the hardware, of course, but you also get a platform to run applications on, right? Basically an operating system. Like if you went somewhere and bought a new laptop, you put on whatever apps you want. And then software as a service, it's like going to Facebook and what's there is there. You have some check boxes you can check or uncheck for your own preferences, but you're not really going to go into Facebook and modify, say, their photo upload system. Okay. All right. Those are your three. And we can skip over all this because that's just copy. Okay. So let's do one more question, and then we got a little bit of topic about other things. They do 17? Yeah, okay, let's do 17. Because this is relevant too. All right. Tight and loosely coupled systems. All right. That seems like a good number. I'll give you 10 seconds. 8, 7, 6, 5, so on. All right. Ding, 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 ding. Okay. What's the right answer? C, yes, tightly coupled systems. Superior performance, right? What's the example? It's gears, right? Gears in a high performance engine. If they fit together really well, the engine is going to run better in a variety of ways, but it's going to be harder to modify. You can't just go to Target and replace it with some, lesser quality gear and have it work the same way. Okay. Good. Well, that was good. Okay. All right. I'm curious, since you're all here today, and we have this instructor-student relationship. How many of you wish there were exams in this course? How many of you? Yeah, a few. You feel more centered? Do you feel kind of untethered from reality? That I'm just here talking, and mostly not, but a few people. That's okay. I wondered. Okay. That's it. Just a few. Most people are like, oh, thank God, there's no damn exams. Is that fairer? Yeah. Okay. Interesting. I do sometimes feel that students, in a way, there's definitely a subset of students that, in a sense, they're happier to have their work recognized, if that makes sense, right? They want to put in time to learn something, and then afterwards they want to get that little dopamine rush from getting an A. I don't know. All right. But I think one of the problems that a lot of professors have is that I think professors tend to overestimate how concerned students are about grades. Because number one, right, most professors were like high achieving students, obviously. But number two, the students that we interact with the most are the ones who come in saying, hey, can I get a couple points of this because I need an A, blah, blah, blah. And, okay. Anyway, just kind of curious. We had a little time. Okay, let's do this. So cloud vendors, this is the last bit. All right, comparisons are difficult. So remember the other day we were talking about the ethical issues of being a scholarship fund administrator, right? And you want to give it to students who are likely to complete the program, but there are some issues about how you go about determining that. Well, very similar problem for picking a cloud vendor, right? If you're a business, obviously you want to pick the best cloud vendor, but it's hard to get the data to do that. Number one, just all by itself, the vendor selection process in a corporate environment is a big pain, right? Corporate things, they tend to have to go through different layers of approval. And at every layer, people have to justify exactly what they've done and why. And they'll say, oh, we looked at such and such different vendors and they had these attributes and these costs. And we thought that this one is a better fit for our needs because blah, blah, blah. It's not something you're going to do over and over frequently because it is a substantial thing to make a decision like that. Okay. Number two, like a lot of things in life, it's hard to learn about the differences without direct experience, right? Like picking a university, right? I'm sure you all got brochures from UIC that said, UIC, a happy place, right? Lots of smiling students. Yeah. No, nobody got brochure. They don't do brochures anymore. I mean, if you see an ad for any university in the United States, it's not going to have a bunch of sad, mopey, emo-looking students wandering around campus, right? They're all going to look, oh gosh, they're so thrilled to be there. But, obviously, some people UIC is a better fit than for others. All right, so same thing with cloud, right? It's difficult to learn about those differences without direct experience. One thing in particular, there's a sampling issue. Okay, so we're going to bring in some low intensity statistics. Okay. So thank you. Okay. Suppose that there is a cloud deployment problem, right, that affects 10% of deployments like yours, but unpredictably. Okay. So you're not going to be able to know in advance that this is going to be a problem. Because if it were, you'd do something about it, right? But it happens that in reality, this is a problem that could occur, but you don't know. Now, suppose you have data from 10 comparable businesses, right? Well, with that 10%, there's about a 50% chance that exactly one has experienced the problem, right? In which case, reality matches your sample, which is nice, and you'll think it's 10%. But there's about a 40% chance that none have, right? Even though in reality, the probability is 10%, but it just happens that these 10 that you have knowledge of, nope, didn't happen to them. So you underestimate the problem, okay? Likewise, there's about a 10% chance that more than one have experienced it. So you overestimate the problem. Basically, you're you're only about 50% likely in this case to guess right and say that, oh yeah, this is a 10% problem, right? And if you imagine that there are a lot of different problems that can arise in these kind of cloud deployments, getting a good idea of what's going on, right? That is not necessarily going, just based on this kind of sampling and looking at comparable firms, it's going to be a challenge. So really, yeah, in a lot of cases, you have to get in there and try it to see how it works. But problem is it's such a pain to, do a major partnership with one that, it's not easy. Like even UIC, we started doing some stuff with Amazon Web Services and bringing in various content direct from them into our courses. Like I taught IDS 410 database course in the spring, and they were bringing in, that year, they were bringing in what's called the AWS Academy, where people it's like a sandbox for doing cloud stuff, basically. And that was new. And they'd been working on this partnership for like a couple of years, right? Is how long it took to say, bring Amazon just into a classroom at UIC, not even for business purposes, really, So these things take a while, and you're not going to just like switch with a whole bunch you might dabble in a few, but you're not going to make a large scale effort for one or the other. Okay. So ideally, it would be real nice if there was something like consumer reports for cloud services. Now, consumer reports is probably a little bit before most of your time, but what it was is a product review mechanism, right? So what it would be and if you went to your grandparents all over America, they all subscribe to consumer reports. So it'd be stuff like, here's, 15 or 20 brands of vacuum cleaners, and here are their pros and cons on different attributes, right? Or different kinds of frozen pizzas, whatever. So it would be nice to have something like Consumer Reports for Cloud, where they looked at all those different attributes of cloud and enabled you to have an apples to apples comparison. But the reality is that sort of thing really doesn't exist. And part of that is some deliberate concealment of the details. So I'm going to go into Amazon's pricing. So just to say, AWS cloud pricing. This stuff is, let's see, there we go. Product and service pricing, boom. Okay. So, you can eventually find it, right? So how do you look? Let's do where's, this is a different one than what I had today. Huh. All right, here we go. Oh, this is this is the old one I used to look at. Okay. So if we're looking at any one of these different ones, let's say we want to use query data and S3 using SQL, Amazon Athena. Sounds good. All right. So here you can find out, this is a pretty simple one, actually. So you can look at different categories, like with Spark. I've mentioned Spark. It's like a big data number crunching thing where you have big problems and you break them into sets of small problems and recombine the results. Spark is like that, except you do it in RAM, so it's really fast. The old one, Hadoop, you did it on disk. Let's see. Okay. Anyway, geez, this is not a great example here either. Let me see. I'll look up EC2. That's what I really wanted to get. I just didn't Google. I thought it'd show right up. AWS EC2 pricing. Okay. There we go. All right. So this is the one I used earlier. So they have a bunch of different options, right? On-demand pricing, data transfer within the same region, which is going to be less, different kinds of, IP addresses, unlimited limited mode pricing. And you'll see they have all these little details, right? So this here, right? 758 available instances. Here are things you could get. If you wanted to be thorough, you'd have to look through 38 pages of all this to find what you were looking for, right? It's a lot of work. Now, if you're a full-time cloud service consultant person, yeah, you get used to navigating this, right? But if it's your first time doing this, it's going to be a big headache. There's a lot of different issues as far as location type, operating system, instance type, right? There's different optimizations there, different kinds of how many CPUs you get at the same time, things like CloudWatch with like elevated security, stuff like that. It's a whole big complicated thing. So that's complicated enough. But then the second thing is Amazon's the leader in cloud. So because they're big, you would think, you expect all else equal, they probably are a little cheaper than the other ones, right? So to Amazon's competitors, it's in their interest to make it, in many cases, impossible to do a direct apples to apples comparison. Because if you could say, oh, here's Microsoft, they're offering exactly the same package as Amazon for 5% more expensive, you're not going to go with Microsoft, right? But if you mix things up a little bit, give a different point of comparison, then people might be, that looks okay. Or Amazon might be relatively expensive in some things, cheaper in others, right? And they try to mix it. Amazon itself tries to mix up the availability of information so that in those areas where Microsoft is cheaper, it's hard for people to see that. And people will just assume Amazon is cheaper because it's the biggest. Okay, so a lot of these vendors really don't want you to be able to do direct apples to apples comparisons. Okay, so because of that, but it is worth mentioning, you're pretty much guaranteed to save money by going to the cloud. And that's not the same as saying you won't spend a lot, right? So the example we did when I talked about this in Paint, let's see if I can get through all this fast. Oh, I'm not going to get through that. Nope. Okay, so when I talked about that stuff about demand growing and eventually you were wasting like $1 billion a year, like 900 million, well, if you're wasting $900 million a year, right, you're spending $1 billion. If that spend goes down to say 300 million, you're saving a lot of money, right? But you're still also spending a lot of money. So people say to me, well, are cloud services expensive? And I say, not compared, for most businesses, it's not expensive compared to doing all that work yourself. But yeah, you can spend a lot of money there. So with cloud services, anyway, it's better to consider them in terms of fit, right? Don't just look at the numbers, how much it's going to cost, but say, does this cloud service offer the services we need, with the availability, reliability we need? And are those things likely to be true in the future as well, right? Because that's what a business knows. Okay. Typical things you might want to look at, things like accountability, like is the cloud service regularly being audited? And do you own your own data? Some cloud services, the way they keep the cost down is they tell you, well, you know what? You don't actually own your data. We own it, and we're just nice enough to let you look at it, right? This was a thing with Google Analytics for the ordinary non-premium service. Cost is pretty straightforward. Service guarantees, right? One of the terms you'll see a lot in industry is service level agreements. And that's just a contract for things like how available the service is going to be, right? Like 99.9% of the time, the cloud service is going to be up and running, and they're only going to lose like 1 byte out of every megabyte you upload, things like that. And, if they fail to live up to the service level agreement, then you have legal recourse to, get some kind of compensation. Security, again, you can't really peek behind the curtain of the cloud to see what their security operations are, but you can look at things like if they're being assessed, did they pass the assessments and how well? Do they have a history of data breaches or not? What sort of privacy levels do they offer? And then the last one, usability, right? So usability is really highly variable across individuals, right? What I would think is usable is probably not the same as my grandmother would think. Oh, my grandmother's long gone. My mom would think is is usable. Several years ago, I used to teach IDS 520, or half of it. I taught the network infrastructure part, and I had to do some stuff in cloud. So it was the first time I'd used Microsoft Azure. I went in there and I did some stuff, and it took about half an hour for me to get everything set up. But about 20 minutes of that was me trying to figure out which step I skipped over in the process that made me unable to do the stuff, right? So if I'd been paying a little more attention, figure like 10, 15 minutes for me to get it up and running, right? But other people, if, they don't have a history of working with similar things, yeah, it's going to take longer. Okay. Now, last stuff, cloud security. Okay. So one of the things we take this as a dogma, right? Cloud service security on average is better than most private information security, right? Most individual businesses, but it's opaque. You can't look behind the curtain and see how they're doing it. So you kind of got to say, well, yeah, it's probably going to be better. The logic, if nothing else, any cloud service that had bad security at this point would have ceased to exist, right? There might still be vulnerabilities there, but I mean, cloud hacks do happen, but hacks happen everywhere. So it's also true, cloud services are not invulnerable, right? Hacks, other data breaches, they do happen. So there is a reduced risk of security problems, but the actual risk reduction is hard to know. And sometimes you can have things that are considered, that are sort of considered breaches and sort of not. One of the big things in recent years has been scraping. So you know how you can go to Facebook and do a search for somebody and it'll show you a list of people that might be that person? There's a lot of applications like that out there where you can do a search and grab a big batch of data. And what the bad guys would do is they would capture all that freely available information and bundle it in a way that it made it useful for bad guys, right? So for example, if you want to target somebody based on location or age or gender or any other demographic information, you might have all that information in one place to do that. Okay, so again, not strictly speaking a data breach because it's all publicly available information, but still a concern. So in recent years, a lot of those applications have gone from, allowing massive piles of data to be available to you can only search for specific people and get like a small set of matching results. Other cloud-specific concerns, data leakage prevention, right? If the cloud has been breached and some bad guys are getting your data, how would you know? Is there any way you can know? Or do you have to just hope the cloud eventually detects it? Improper cloud configurations, allowing other tenants access, right? Talked about the iCloud hacks. So if there's an example where, somehow the servers or the databases are not secure enough, some bad guy might be able to get there and access other people's data on the same hardware. And finally, deletion assurances. This is something, if you say, well, we've been at Amazon for 5 years, but now we're leaving and we're going to Microsoft Azure. Amazon, please delete all our stuff. Well, you got to hope they do, because you don't really have a way to go back into their system and check for it. So there are some, even though cloud security, generally it's a winning thing to go to the cloud, but there are some specific unique problems that happen just because of the cloud. Okay. All right. Well, if there's no questions, I guess that's all I got. It's been a hoot. We'll see you next time.